Hello, and thank you for joining me for our last section of the gases and energy unit in this course. And so today we are going to talk about, you will be able to determine the mass of a given volume of gas. We're going to talk about pressures. You'll be able to determine the total pressure of a mixture given the different partial pressures, or vice versa. So like I said, you're going to be able to calculate the partial pressure within a fixed sample of a mixture. So that's what we're going to talk about today. Let's get rolling. For starters, you've heard of this guy before, the guy named Avogadro. He's the one that determined that 1 mole of substance is equal to 6.02 times 10 to the 23rd molecules of that substance, or atoms of that substance. He also determined that the volume of a gas is directly related to the number of molecules, as long as the pressure and temperature are not changed. So under a constant temperature and pressure, you have a volume and a number of moles, and a volume and number of moles. As long as the pressure and temperature stay the same, that's where we're at. And he determined that the molar volume, so the volume of 1 mole of gas at STP, so if we have standard temperature, standard pressure, remember standard temperature is 0 degrees Celsius or 273 Kelvin, standard pressure is 1 atmosphere. The volume of this gas is going to be 22.4 liters. And so his conversion factor, the one you're going to use, is 22.4 liters per mole of gas. So we can go from volume to grams or grams to volume is what we're going to do here. So what is the volume of 64.0 grams of oxygen gas at STP? And so I know I have 64.0 grams of O2. I know that my molar mass of oxygen gas is 32 grams of O2 for 1 mole of O2. And now I know that I have, in 1 mole of gas, I get 22.4 liters of gas. And so if I take 64 and divide it by 32, I'm going to get 2, and 2 times 22.4 is going to be 44.8 liters of oxygen gas. And remember, this is at STP, so this is at standard temperature and standard pressure. I'm going to have you work through the second one. So I want to know how many grams of nitrogen are in 5.6 liters of the gas. And if you get, when I ran it, I got 7.01 grams of nitrogen. So run it through, see what you get, see how you do, and we will continue on. We also have this law of pressures. And Dalton, the guy that created the atomic theory, he had a law of partial pressures. He determined that the total pressure of a system is equal to the sum of all the individual pressures of the gases in the container. To me, that's common sense. So your total pressure is going to be equal to your pressure of one substance plus your pressure of another plus your pressure of a third. So for example, a 10-liter tank contains propane gas at 300 torr. Another 10-liter tank contains methane gas at 500 torr. In preparing a mixture, the gases are both put into a 10-liter container at the same temperature. What is the pressure of the mixture? So because my volume didn't change, I had to keep a constant volume, I have to keep a constant temperature, which we've done. I have P total equals P1 plus P2. So P total has to equal 300 torr plus 500 torr, which is going to mean my P total is going to be 800 torr. I can give you the pressures in different units. You need to make sure the units are all the same, and you have to make sure if I change your volumes, you're going to have to use the pressure and volume relationship as well. But this is Dalton's Law of partial pressures. All right. The last one we're going to talk about today is Harry's Law. He determined, he looked at the amount of gas that will dissolve in a liquid at a particular temperature is directly related to the pressure of that gas above the liquid. So he looked at how you can dissolve a gas in a liquid and how that's related to pressure. And this is how pop works. So when you buy pop has carbon dioxide dissolved in it. If it's cold pop, it has more CO2 dissolved in it. If it's warmer, it has less. But the question is, why does it fizz as soon as you open it? Why does it make the sound of rushing air when you open it? Well, inside that can is very high pressure. And they do that pressure to keep the carbon dioxide in the pop. When you pop the lid, that pressure is decreased, so your carbon dioxide escapes. And that's the gas, that's the air you feel rushing out. So when you open a bottle and you twist the lid and you feel that air come out, that's carbon dioxide escaping the liquid and getting out of the container, along with the pressurized air above it. But that's what's happening. All right. This was kind of just a short, quick, only a couple things in here unit section. So answer these questions. There's 3 of them here. I have a couple more on the next slide. So pause this screen, answer these questions, and then you can unpause it and answer questions on the next slide. So here's your last set of questions for this unit. And so work through these. If you have questions, please let me know. Otherwise, I look forward to finishing out the year with you, and I've enjoyed our time together.